All right, your signature assignment is out on Canvas. So that's how you're going to download it. You have 11 pages. So you're going to have to take pictures of each completed page, import them into a Word document in order, and then name it appropriately. But if I walk you through problem number 1, you're going to be able to do the rest of them. Okay, so basically you're exploring how a ball, if it's thrown upward, affects in different types of gravity. Okay, so I've got, we're going to throw 2 different balls on Earth. We're going to throw 2 different balls on Mars. We're going to throw 2 different balls on Venus and 2 different balls on Jupiter. Okay, so that's what you're going to do. So your setup on every page for all 8 situations is the exact same thing. So it says, find the height function in terms of time. So look at the notation. You've got a second derivative, which is going to be acceleration, okay? And it's in terms of time. So you're told acceleration due to gravity is a negative 32 feet per second per second. That's not a typo. That's how you measure it. And we're pretending that there is no air resistance. So for number 1, you want to find the height function in terms of time. So the height function is simply negative 32. Okay. Well, now what we need to do to move from a second derivative to a first derivative is we need to integrate. So underneath here, you're going to show all of your work. Okay. So the integral of a negative 32 dt is going to be negative 32t plus c. Okay, so your second blank is going to be a negative 32t plus c. But now for the second part, we need to resolve the plus c. So you're given an initial condition. If your initial condition is at time 0 and you get 30 for an answer, that means you're going to say y equals negative 32t plus c. Well, if your y coordinate is 30, and if your t value is 0, then c must be 30. Okay? C must be 30. So your answer on this one changes to a negative 32t plus 30. Okay, so now I'm going to move from here over to here. So now I need to take my specific information and I need to go from a first derivative to the original function. So I'm going to integrate negative 32t plus 30 dt, and I am going to get negative 16t squared plus 30t plus c. So that's the general solution. So I've got a negative 16t squared plus 30t plus c. But again, I need to resolve my initial condition. So I know if I shove in a 0, so we'll say y equals negative 16t squared plus 30t plus c. If I shove in a 0 for t, that'll go away, that'll go away. Then my answer would be 6. So c must be 6. So my final equation on this first one is a negative 16t squared plus 30t plus 6. Okay? So that blank is done, and this first part of the problem is now done. So it says, what time does the ball reach its maximum height? In other words, when does your first derivative equal 0? So I'm going to take the information for my first derivative, which is a negative 32t plus 30, and I'm going to set it equal to 0. Okay, so subtract 30 from both sides, and then divide both sides by negative 32. So I get negative 30 over negative 32, which is actually the same thing as 15/16. Okay, and 15/16 in decimal speak is, 15 over 16 is going to give you 0.9375. So if you want to round it to 3 or 4 decimal places, that's fine. So 9375. Okay, that is the time that the ball reaches its maximum height. So what is the maximum height? Well, if this is the height function, then I can Shove that, that's a lie. If, grab this one, sorry, this is the height function. So grab this completed trinomial and evaluate it at 0.9375. So I've got negative 16.9375 squared plus 30 times 0.9375 plus 6. And when I do all that mess, I end up with, hang on, negative 16.9375 squared plus 30 times 0.9375, which I just did backwards, 375, and then plus 6. All right, so I get 20.0625, okay? So that is going to be the maximum height of the ball. It's going to max out at 20 feet. All right, the final one says, how long will it take for the ball to hit the ground? So again, that's your second derivative is acceleration, your first derivative is velocity, and your original function is your position function. So I want to know, when is this ball going to hit the ground? So what you're going to need to do is use Pythagorean theorem here. So you've got a negative 16t squared plus 30t plus 6. And you're going to put it in I just said Pythagorean theorem. What on God's green earth? Quadratic formula. So I've got a negative 30 plus or minus the square root of b squared, which is 900, minus 4 times a times c, all over 2a, which is a negative 32. Okay, so when you plop this in your calculator, sorry, you've got two answers, because it's quadratic, so you've got two x-intercepts. Sorry, y'all. When you do that, remember that time is going to be positive. So you're going to want the one that will give you a positive answer. So negative 30, and then when I shove this in here, hang on, square root of 900 minus 4 times negative 16 times 6 is, and that gives me that mess divided by negative 32 is, and I get 2.0572. So 2.0572. And that is my final answer for this page. So 2.0572. Now, you're going to repeat this for pages 2, 3, 4, 5, 6. Hang on, keep going. All the way through 8. This one we're going to come back to. This is page 9. I'll come back to that in a second. But here's page 10. So I already filled this in for you so that I wouldn't bore you with time. All right, so what did we find was my initial height problem on page 1? It was negative 16t squared plus 30t plus 6, okay? What was my initial point? So at time equals 0, the ball was at a height of 6 feet. So your initial point is 0, 6. Your max height point is a combination of two different answers. So this is when it hit the max height, and this is the max height, okay? So two different answers, because if you'll remember on page 1, here's your two different answers, okay? And then finally, when does it hit the ground? Well, it hits the ground after 2 seconds-ish, and the height at the ground is 0. So you're going to fill in the rest of these tables here. So hang on one second. This is the final pretty picture, is the last page of this whole thing, and I have printed, or I've made a graph for you. So this is the graph. This is your initial point, so it's at 0, 6. This is the maximum height of the ball, which is just shy of 1 and just a little bit more than 20. And then it hits the ground, sorry, at about just over 2 seconds. So you probably want to label that as Earth 1, okay, or label it as Graph 1, whatever. I'm so sorry. But you'll have 7 additional parabolas, and you're going to end up using this whole thing, okay? So I would color code them if I were you. I would make Earth, both of them are blue, or both of them are pink, or something. And then make both the Mars ones the same thing, so that when I'm looking at it, I can see rapidly that you've graphed the right things. Now, back up the train. What we're going to do is go back to page 9. And this is where you got to do a tiny bit of research. So question 9 says graph all of your functions, okay? Question 10 says write an original paragraph speculating about what happens to the original curve with change, either up or down, to each parameter, which would be gravity, the starting point, and your initial velocity. Use your results to defend your argument, okay? Research how gravity and velocity affect the motion of the ball and explain why there are differences in the maximum heights and final distances of the balls. So when we say research, see that big word right there? You need to find at least one reliable source, which is not Wikipedia. Okay, at least one reliable source. And at the bottom of this page, I need you to give me the official citation of where you found your information. I don't care if it's in MLA, which is how all of your English papers have been done, or if it's in APA, which you may or may not have done. I don't care. Okay, as long as it's from a reputable source, not Wikipedia, and as long as you put it in your paragraph. I need this to be about 300 words long. Okay, so about 300 words. So it shouldn't be more than this page. So write it neatly so I can read it. Now, here's the hard part. You are going to take a picture of each and every page. Okay, so take your cell phone. Take a picture of this page. Take a picture of this page. Take a picture of this page, and so on and so on and so on. So you're going to give me 11 pictures. Make sure that your name is here. Okay, so I am going to say first name, last name. Okay, make sure you put spring 2020. And now what I need you to pay attention to is how you are going to submit it to me. So this is what you're going to do. You're going to import all 11 pictures. You must show your work. Okay, import all 11 pictures from this packet into a Word document. Make sure that they are readable. Make sure it is 1 page per page. Okay, so don't squish all 11 pictures on 1 page. Import them into Word in order. Please put them in order. And then choose Save As. Okay, and scroll down for the file type and you'll see PDF. You're going to send me 1 PDF. Now, pay attention to how you are going to name it. You're going to say 2413. Your section number is either 41 if I had you on campus, or DMA1 if I had you in Maypearl. Okay, so either 41 or DMA1. And then you're going to name it last name, first name. And then it's going to be a .pdf, which it'll do by itself. But please follow instructions. You're going to name it 2413 and then a space. Don't put a period. Don't put a dash. Don't do anything. No punctuation. So 2413 space. And then either 41 for on campus or DMA1 if you're in Maypearl. And then another single space, your last name capitalized, space, your first name capitalized, because I'm going to get about 100 of these things and I just need to drag and drop them into folders. Okay, so please don't name it anything else. Don't name it my last name and my first name. Name it your last name, your first name. Don't name it last and first. Okay, so this is how you're going to send it to me, and you're going to email it to me at sage.bentley and then at navarrocollege.edu. Okay, don't submit it through Canvas, email it to me. And please let me know if you have questions.